All right, guys, welcome to day one, part two of our lesson. So we kind of left off talking about what slope looks like, and then in function notation and just regular x's and y's. And so that's how you represent the average rate of change. Okay. So what I want to do is just some practice questions. So I'm going to say calculate the average rate of change over the given intervals. All right, so the first one, I'm going to give you the function f of x equals 5x plus 7. And then the domain that I'm going to give you is from -2 less than or equal to x less than or equal to 3. Right? Now, if we were in class, I would give you a few minutes to try this one on your own because we're flipping and watching a video. I think the easiest thing to do is to quick calculate f of -2 and f of 3 first, and then we'll go from there. So just kind of off to the side here. You can do a little mental math. You could grab your calculator. I don't care which way you do it, but the idea of 5 times -2 and then plus 7, right? That's going to give us -3 because it'd be -10 plus 7. If we do f of 3, plug in a 3, so 5 times 3 would be 15 plus 7. That's going to give us 22. So to calculate the average rate of change, we would do f of 3 minus f of -2, and then all over 3 minus -2. Now, the order in which you do them doesn't really matter. So you could have done f of 2 minus f of 3. Just in the denominator, make sure that it matches. Right? So if I take my values, I got 22 minus -3 all over 3 minus -2. Both cases, we go plus a positive, so this will give us 25 over 5, and we come out with 5. This should not be surprising because when you think about it, if average rate of change is synonymous with the slope, and this is a linear function, there's the slope right there, all right? So it's the same as the slope. So any linear function I give you, if I ask you for the rate of change, you can just tell me like, hey, I don't even need to show the calculation no matter what the domain is. It is just whatever the slope is. So if for the second example, if I said, f of x and then equals -1/2 x minus 2, whatever domain I could possibly give you from here to, wherever, it wouldn't matter at all. Your answer would be that the average rate of change would always be equal to that slope right there. So it'd just be -1 over 2, right? Now, if it's a non-linear function, so you have to be able to recognize when it's not linear. So something like x being squared, or if you have an exponential or something like that thrown in. So let's do x squared plus 1. That one does not fit that basic old, y equals mx plus b format. So in this case, you'd actually have to calculate it because you can't just look at the slope value. So if I say 3 is less than x is less than 5, let's use that little chunk for our domain, right? Same thing. You can do the work as you go. It's kind of helpful just to calculate quickly off to the side. So 3 squared plus 1, this would be 10, right? And then f of 5, so 5 squared and then plus 1, that would give us, 26 here? And so then when we go to calculate the average rate of change, right? Just being a little lazy with my notation there, we would have f of 5 minus f of 3, and then all over 5 minus 3. So that's that new way to kind of show it. So it would be 26 minus 3, and then all over 5 minus 3. That's going to give me, oh, just kidding. F of 3 was 10. Ooh, this is where I have my whiteout at home with me. See, sometimes I'm prepped and ready. All right, that should be a 10. This will give me 16 over 2, and it comes out to be 8. Now, what does that mean visually? Well, think about this graph. You know what x squared looks like. That's a plain old parabola. The plus 1 would shift it up 1 unit because we just finished talking about our transformations unit, right? And so it would shift up so that it would cross at 1, and it would look something like this. So what I was asking you guys was, what is the average rate of change, or what is the slope between where 3 and 5 are. So over here at 3, what you calculated was this would be the point 310, right? And then at 5, this would be the point 5 and then 26. So it's not the most accurate looking graph, but that's okay. If we were to connect the dots between those 2 points, so I'm going to grab my straight edge here because I happen to have it. That would be the little line between them. It's a little tough to see because mine isn't perfectly drawn, right? But what we just calculated, that 8, that is the slope of the segment that connects those 2 points right there. That's really what you're actually calculating, right? So visually, you should look at it and be like, yeah, that's a pretty steep segment. A slope of 8 should hopefully make sense there, right? So with that being said, when it's linear, we said it's always the slope, right? Whereas in this case, depending on the interval, the rate could possibly change. So the interval here, it made sense that it was positive. If the interval was maybe somewhere from like here to here, then I would have a rate that's negative because I would have a negative slant over here, all right? So I'm going to say for non-linear functions, the average rate of change can vary, or maybe I'll just say varies, depending on the domain interval. So it could be positive in one place, negative in another. All right. When you flip it on over, there's a question that's sort of set up for us. It's the only thing on that page. So when you flip on over to that next page here, it says the table represents a linear function. Find the missing values. So the fact that you're told right off the bat that it's a linear function, what that should mean to you at this point is that there is then going to be a constant rate of change or a constant slope. Right. So you're giving it to you this way. You could also look at, a normal table of values that way. Doesn't actually matter. Right? There's a couple different ways to do this. We're going to talk about linear regressions. We would be able to take advantage of that once we review those. But something to keep in mind is if you calculate the slope between any 2 points, it would need to remain that way for the rest of them. So I'm going to do that. If I calculate the slope, remember, change in y over change in x. So the only 2 points that you know all the values of are right here. So here's an xy point, here's an xy point. So if I do the change in the y values, so -5, -1, so I'm going to go 1 minus -5. So you can think of it as y2 minus y1. And then change in x's, so 5 minus 1. This would give me 6 and then over 4. And so that is the slope of this line, all right? There's my slope. So if I need it to stay consistent, that means for every 3 it's going up, it's going over 2. Now, could you do this by just kind of filling in the values and like walking on a graph? Absolutely, all right? So you could graph it to see it visually, or I can kind of put in just, all right, a y here. So what I know is I have some point 11 comma y, and I have these 2 other points to play with. So remember, this is the point 1, -5. This is the point 5, 1. So now that I know what the slope is, I could actually work backwards from that. So I'm not going to fully finish this, but I can give you an idea of what I mean by that. So if I use the point, let's use the 5, 1. This way we can avoid the negatives. And then I'm going to take my other point that I'm working with, which is 11 comma something. All right. The slope should be 3/2 because it's linear. So it's going to stay 3/2 no matter what. So let's actually calculate the slope using these 2 points. So the slope would be the change in y's. So y2, oops, I don't need the 2 there though. Sorry, I said it, but I didn't need to write it. So y2 minus y1, which would be y minus 1, and then over the change in the x's here. So 11 minus 5. So this would give me y minus 1 over 6 has to come out to equal 3/2, right? This is a little equation I've now set up for myself. Cross multiplication will get the job done. So if we cross multiply here, I do 2 times y minus 1. 6 times 3 will give me 18. I have a choice. I can distribute that 2. I could divide it out. Lots of ways that we could finish this problem. So if I add the 2 on over, this will give me 2y equals 20. And y should come out to be 10. All right. Now with that being said, that means back in my chart, I'm going to slide back up here. Right? What I can do is I could then kind of graph these and see, like, is this making sense? So I don't have graph paper sitting next to me, but I can still give myself like a reasonable graph to kind of look at. So I'm going to slide back up so you can see what I'm writing here. So 1 point was 1, -5. So over at 1, be down at -5. Right? And then the next point was 5, 1. So kind of over to 5 and up to 1. So even without a perfect scale, it should be looking something like this. So then my last point that we just said we should have is the point 11. So up here and then up to 10. Now, would I be able to perfectly tell, like, oh, of course I did it right? No, not perfectly. But if you were on graph paper, yes, you could. So don't underestimate literally plotting some points and using that visual to help you. All right. Tonight's homework, though, more about calculating, and we'll talk about that. I shouldn't say tonight's homework. We'll talk about that in class. All right. Thanks, guys.